In this video, we're going to talk about density. Now, density is a ratio between mass and volume. Now, mass has to do with how much something weighs or how heavy it is, whereas volume has to do with how much space it takes up. And when I compare the mass and the volume, I get what we call density. Now, there's a formula for density. Density is equal to mass divided by a volume. And that's why I called this a ratio, because a ratio is nothing more than just a fraction. Now, you'll see some different units associated with mass, volume, and then, of course, density. So, for instance, mass, which again has to do with how much something weighs, you may see things like grams, pounds, ounces. You may also see kilograms. But when we talk about volume, we may use, and again, that's how much space it takes up in a shape. It could be a lot of different shapes. We learned about pyramids and cones, spheres, cubes, triangular prisms. So volume could be represented in centimeters, cubed. Remember, everything here is to the third power. Inches cubed, millimeter, feet, miles. We could go on and on. So we have volume, which again is represented in like linear units. Mass is how much something weighs. And when we talk about density, we're comparing them. So it may be something like grams per centimeter cubed, or pounds per inches cubed. Okay, so density represents both of these because I'm comparing those two. So I also want to show you some shortcuts. The same way that we know the formula for density is D equals mass divided by volume. Since I can solve for D, I can also solve for mass or solve for volume. So some shortcuts: if I was solving for mass, I would multiply the density and the volume. And if I was solving for volume, I would divide the mass divided by the density. So I could be asked to solve for the density, I could be asked to solve for the mass, or I could even be asked to solve for the volume. Now again, keep in mind, once I find the volume, that volume could be associated with a lot of different shapes. So you have to remember that part. In this problem, we're given the density of gold, which is 19.32 grams. We're also told that it is a pyramid with a height of 2.13 meters, and it has a mass of 2.98 and 7 kilograms. The base of this pyramid is also a square. And then it wants to know what are the dimensions of the base of the pyramid. Okay, so first of all, it gave us a lot of information and it's asking us for something very specific. So, well, first thing I'm going to do is draw the shape, because I want to make sure we know what shape we're trying to make. And they said it's a square pyramid, so that means the base of the shape is a square and all sides are the same on a square. And it comes to a point because it's a pyramid. And they also gave us a bunch of information about this pyramid. They told us that the density of the gold is 19.32. It told us the height of the pyramid is 2.13. It told us the mass was 298.7. And the only thing that it did not give us was the volume itself. So in order for me to find the dimensions of the base of the shape, which means what is the length and what is the width of this shape, I probably should find the volume first. So the formula to find the volume is mass divided by density, both of which was given to me. So all I'm going to do is plug those into this formula, and I'm going to find volume. So when I plug in everything that I know, I get 298.7 divided by 19.32. That gives me a volume of 15.461. So now that I know the volume of this pyramid, I can work backwards to find the length and the width of the base of the shape. So let's recall what is the formula to find the volume of a pyramid. So to find the volume of a pyramid, I'm going to take the area of the base of the shape, which in this case is the side squared, S times S, times the height of the pyramid divided by 3. And remember, all the shapes that have a point are all divided by 3. Now, I know the height, and I also know the volume. So when I plug these numbers in, I'll be left with the sides, which is what the question was asking me for in the first place. So here I'm going to plug in everything that I know. I know the volume is 15.461. I'm going to set it equal to S squared times the height divided by 3. Now again, my job is to try and get S by itself. So the first thing I'm going to do is multiply by 3 on both sides, because whatever you do on one side, you have to do to the other. The cancels over here. On this side, I'm left with 46.383 equals S squared times 2.13. To get S squared by itself, I'm going to divide by 2.13 on both sides. So now I have 21.77605 is equal to S squared. And the final step to get S by itself is to take the square root. And the square root of this is approximately 4.6. In this problem, we talk about density in a little bit of a different way. So let's pick out the information that we need. It says that during an observational study, the same type of rabbit is raised in different zones. Zone A has a radius of 20 miles. So already the fact that it's telling me there's a radius, I know that the shape I'm dealing with must be a circle. And has approximately 24,000 rabbits after 1 year. Zone B has a radius of 36 miles and has approximately 75,000 rabbits after 1 year. Determine and state which zone has the greater population density. So that's what we're looking for, the population density. So basically I want to know for every, let's see what they gave us here, miles. For every mile, how many rabbits will I find? Every time I do a square mile, how many rabbits will I find? Well, first of all, this is geometry, so let's draw the shapes. They told us some information about Zone A and Zone B, so I'm going to draw those images. It says that Zone A had a radius of 20 miles and 24,000 rabbits. And Zone B had a radius of 36 miles and 75,000 rabbits. And it wants to know who has the greatest population density? Well, if I have a radius, like I mentioned earlier, I must be dealing with circles. So let's draw the two circles that are described. The first circle I know has a radius of 20 miles, and the second circle I know was a little bit bigger, and that one was 36 miles. So what I first want to do is find the area of both circles. So I'm going to use 3.14, and I'm plugging in the radius for both of them. 20 squared is 400 times 3.14. And when I multiply 3.14 and 400, I get 1256 meters squared. So that is the area of zone A. Now I'm going to find the area of zone B. When I plug in 3.14, this time the radius is 36. 36 squared is 1,296. 1,296 times 3.14. So here I get a final answer of 4,069.44 inches squared. Now this is the area of zone B. Now the question is, who has the greater population density? So remember, this one has 24,000 rabbits, and this one has 75,000 rabbits. So here all I need to do is compare the density for both of them. So I know that we typically do the volume, we do the mass divided by the volume, but in this case we're going to divide by the area. So I'm going to take the mass divided by the area, which in this case the mass is the number of rabbits. I have 24,000 square rabbits in how much space? 1,256 meters. So when I actually divide that, I can figure out that for every 1 meter, there's 19.11 rabbits. Now obviously there's not really 0.11, but that's the answer. Now this one, when I compare the mass to the area, the mass this time is 75,000 divided by 4,069.44, right? And then I'm going to get here 18.43 rabbits. Well, which zone has the greater density? Zone A has the greater density. They have more rabbits per meter, per square meter inside those circle areas.